So, good morning, dear students.
Good
Good
morning.
morning,
Good
ma'am.
morning.
Good
Good
morning.
morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
Good
Good
morning, ma'am.
morning, ma'am.
That's all. Okay. Now, like few students are awake and are attentive in the class. I don't know about rest of the students, right?
Good morning, ma'am.
Good morning, ma'am.
Good morning,
Good
Good
ma'am.
morning,
morning.
ma'am.
Good
Good
morning.
morning, ma'am. Good morning, ma'am.
Good
Good
morning.
morning, ma'am. Good morning, ma'am.
Good morning. Good morning. Chalo. Now, yesterday's X1 batch practical I didn't take. Today, I am going to discuss the practical only because, like you see, whether I take it for one batch or I take it for all the batches, the experiment remains same, and ultimately you are taking some screenshot sort of thing. So please take out your notebook and pen in which you can write those things. There is a small experiment based on idometric determination, um, titrimetric analysis. Now we are going to determine today dissolved oxygen. Dissolved oxygen present in water. Now boiler troubles we have already discussed. So we know that um dissolved oxygen is present in water. That is why all aquatic flora and fauna is able to sustain in the water. Right now, if dissolved oxygen, which is there as around 8 milligrams per liter at room temperature, if such water is fed into the boiler, it leads to corrosion due to oxygen. So you need to treat water, and like the hydrazine treatment was the best one. So let us read this. Dissolved oxygen refers to level of free, non-compound molecular oxygen present in water or other liquids. It is an important parameter in assessing water quality because of its influence on the organisms living in water. Okay, so it is an indicator of the health of water body and its capacity to support aquatic life. Higher the dissolved oxygen, better is the water quality. Now, why it is so? I think I have discussed this when you have more of nitrates and phosphates in water, which is obtained from the runoff of agricultural field. The water body is rich in the fertilizers or food material. So there, if there is an algal bloom and the water body is completely covered by the algae, then the body becomes the water body is termed as dead water body. Why? Because on the surface of water, um, if there is nothing, then exchange of gases between the atmosphere and water can take place. But if there is an algal bloom, that is termed as eutrophication, then the exchange of gases can't take place, and because of the growth of green algae over the surface of water body or lake or pond, you will find that underneath water is depleted, less in concentration of dissolved molecular oxygen, and that is how then you say that it becomes a dead, and the aquatic flora and fauna also can't live. Fishes and other like aquatic animals can't live in such condition. So eutrophication leads to like this. So if there is eutrophication, then the water body goes dead. Uh, so uh, the presence is not desirable in boiler feed water. Now, dissolved oxygen is very much necessary for all aquatic and flora and fauna, but its presence in boiler feed water is not desirable, and hence you need to treat it by the best method is hydrazine treatment, molecular weight same as that of oxygen, and we find that when you add hydrazine equal, like if this is 8 milligrams per liter and you add 8 milligrams per liter of hydrazine, you are putting converting it into N2 and pure H2O. So this is how you are not incorporating any total dissolved solids or any other thing, and you are getting an inert gas and H2O is formed. So this is the best method. Now coming to the aim. Write down this. Everyone should write in your notebook or the practical pages determination of dissolved oxygen present in the given water sample, and this is done by idometric method, idometrically. Okay, the apparatus is a BOD bottle. BOD stands for biological oxygen demand bottle. Now it is the name of bottle. We are not doing an experiment on biological oxygen demand. For biological oxygen demand, we have to keep the thing for 5 days, incubate it, and then you have to check for the DO present. Okay, so BOD is it is only the bottle name BOD bottle, which is 300 ml capacity, pipettes, burette, clamp, stand, 250 ml conical flask, and so on. Then the reagents. The reagent required is standard N by 40 potassium dichromate solution. Potassium dichromate solution. Potassium dichromate, the molecular weight is 294.21 and its equivalent weight is 49. Why equivalent weight is 49? Because this is chromium which is in plus 3 state. So plus 3 into 2, it is plus 6. So molecular weight divided by 6 becomes your uh, change in valency when it goes uh, from this is the reduced, this is the oxidized form. You get the reduced form K2 Cr2 uh, K2 Cr2O7. Okay.
Ma'am, BOD
Yes.
is bottle name only, ma'am.
Yes.
BOD is bottle name only, not biological oxygen demand.
This experiment is not biological oxygen demand. This experiment is determination of dissolved oxygen. The bottle which you are using for this, because it has the internal volume 300 ml, they are the BOD bottles in which BOD experiment is carried out. But here we are using biological oxygen demand bottles for determination of dissolved oxygen. Things are clear? Many a time students say BOD bottle, BOD experiment, BOD experiment. Here you are using a BOD bottle, but you are doing determination of dissolved oxygen present.
Ma'am,
Okay?
is there any specialty in BOD bottles?
Yes, speciality is there. We will see it further. Okay? I'll discuss this question at the end of the chapter. Okay? End of the lecture. Okay. Coming to standard N by 40, 0.025 normal, normal, it is the normal means equivalent weight, K2 Cr2O7. So, why I am writing these, you should understand that this is a normal solution. So, 1.2258 gram of dry analytical grade K2Cr2O7 powder or crystals are dissolved in distilled water and made up to 1 liter in a volumetric flask. Then N by 40 sodium thiosulfate solution is prepared. Like 6.205 gram of sodium thiosulfate pentahydrate is dissolved in initially some small quantity of water, and then the volume is made up to or made up to in the volumetric flask up to 1 liter mark. So the solution may be preserved by adding 3 drops of chloroform. So you can preserve this solution. Then you need concentrated H2SO4 so that you can prepare a dilute H2SO4 from that. And then concentrated H2SO4 is also required during DO determination. Then manganese sulfate. So manganese sulfate 400 gram of MnSO4 or 480 grams of MnSO4 4H2O is like dissolved. When you dissolve it in 1 liter, it makes a solution which is what you say, the concentration, high concentrate. This is a highly concentrated solution. So you prepare this MnSO4 solution. Then this solution should not give color with acidified potassium iodide and starch. Then you have an alkaline iodide azide reagent. I'll tell you what is the role of alkaline iodide azide reagent. It is a combination of NaOH, Ki, and sodium azide. Okay, so role of each reagent we will discuss when we discuss the theory. This solution should not give color with starch on dilution and acidification. Then you prepare a starch solution as an indicator. So starch solution is used as an indicator in idometric titration. So prepare fresh paste of 0.5 gram of starch with distilled water and pour this into 100 ml of boiling distilled water while stirring. So continue boiling for a few minutes and cool. Then you will need a 10% solution of potassium iodide, okay, which is added in excess. Then you need a pinch of sodium bicarbonate, and then you need dilute H2SO4 to maintain an acidic solution. Okay. Now the theory part of it.
Ma'am,
Yes,
what is AR that?
that is analytical grade. You see, when you purchase chemicals, when you will see the list of chemicals, you have like certain reagents which are synthesis grade chemicals. Synthesis grade chemicals will be somewhat 96 or 98% pure. But when you say analytical grade, it will fall in nines. That is 99.9% or 99.99%. So the purity of a compound is more if you are uh, talking of analytical grade. Now, if the same thing is there, which is for synthetic grade, the synthetic grade will be cheaper one. Why cheaper one? Because the impurities from this particular compound are not removed completely. Here, if you are saying analytical grade means the compound has been recrystallized or washed thoroughly number of times, and then what is obtained is provided to you. Are you getting? So impurities will be less in analytical grade, and your synthetic grade, the impurities will be more. But then when you are going for only synthesis, okay, for example, paranitrocresol, you are preparing from cresol. Now, if you prepare, if you have cresol, which is synthetic grade, you prepare paranitrocresol using some nitrating agent and all. So finally, you are getting an organic compound. So what you do whenever you go for synthesis, you will go for its purification. After synthesis is done, the precursors or the reactants should be removed. So you will wash it number of times, either by water or if it is not soluble in ethanol or benzene, depending on its polarity of the compound. So you give washings, and now in organic compound, this is inorganic compound, but organic compound, you will dissolve it in alcohol, and like you will allow it to stand for some time, scratch at the walls, and get the um, crystalline nature. Like crystals will start forming, or you go for seeding, you get crystal. So then the mother liquor is removed, the first mother liquor. Again, the crystals are dissolved in alcohol. Second time, again you get crystals. The alcohol part is separated out, filtered. So this is how at least three times you have to go for recrystallization. And the third part, what you get crystals, then you will say that these crystals are really very pure, and then you will send it for single crystal XRD, means analysis, right? So to find out what is the structure, what is the composition of it and all. So that is the purity part of your compound. So when you are going for any analysis, any determination, you should use analytical grade. Analytical grade compounds provided by scientific companies like Merck. Merck is one which is a good, like renowned throughout the globe. If you go to US to do some research or any other country, you will find that Merck and Sigma Aldrich, that is so either you say Sigma Aldrich or Merck, that is the most standard chemical, but they will be costlier. वही इंडियन कंपनी का जैसे फिशर साइंटिफिक है या like any other Indian company manufacturing it, same compound will be at a cheaper rate. जो 300 का यहाँ है वहाँ पे 900 का मिलेगा. So that will come from US. They'll see that the purity is there. Purity को भी check करके आपको देते हैं. They perform chromatography and all and say that there is a single spot. Then they provide you. So the price of the compound or the chemicals which you procure is higher when you go for like moving ahead and ahead, finer analysis. अब ये आपको बच्चों को देना है तो like AR grade chemicals will work. लेकिन जहाँ जैसे कोई clinical pathology lab है, they will use the most finest chemical because they are dealing with blood and urine sample. उनके reports directly what medicine should be prescribed में जाते हैं. Okay, coming back, that is enough of this. Okay, these things are clear.
Yes, ma'am.
Okay. Okay, so these are the reagents required. As and when we are writing the reactions, we will see what is the role of each of them. Okay.
Ma'am, what is the full form of AR?
Analytical reagent. Analytical grade reagents. Okay. These are all reagents, and when you procure, it is like that. Okay. Coming to the theory. Okay. Now, theory says that water contains dissolved oxygen, which is used by all aquatic flora and fauna for their survival. But dissolved oxygen causes corrosion in high pressure as well as low pressure boiler. Hence, need to know the extent of dissolved oxygen so that you can treat the water in such a way that water is rendered harmless to the boiler. This much is clear, I have already explained. Generally, hydrazine treatment is preferred to remove DO from the boiler feed water. So inside the boiler, this hydrazine may be added. So DO test helps to assess the raw water quality and to keep a check on stream pollution. So dissolved oxygen test is the basis of biological oxygen demand test, which is an important parameter in evaluating the pollution potential of domestic and industrial waste. Okay, so in biological oxygen demand, what is done? It is allowed to stand with the thing which are there, like biological flora, if it is there. E. coli generally is there. It is never that E. coli is absent. So such microbes, if they are there, they will consume dissolved oxygen. And after 5 days of incubation, you check again how much is. Yes, what is there? Yeah, you can unmute and ask the question.
What is stream pollution?
Stream pollution is like you have number of rivers and streams, okay, and number of industries. छोटा छोटा industry रहता है along the river side. They'll be discarding or disposing their washings and other water into the stream. So that is the stream pollution. Okay, like small industries, number of like food industries, number of things are there. They'll be discarding their washing. Now for washing they may be using lot of detergents, so the detergents are there along with the water. So these things will leach out into the streams, small streams like river ka chota bhai. Okay, oxygen is poorly soluble in water. Solubility of dissolved oxygen decreases with increase in the concentration of salt under a pressure of 1 atmosphere. The solubility of oxygen of air in distilled or fresh waters with low solid concentration varies from 14.5 milligrams per liter at 0 degree centigrade. So at 0 degree centigrade, it will be 14.5 and to about 7.5 at 30 degree centigrade. So the solubility is less in saline water and at a Given temperature decreases with increase in the concentration of impurities. Also with increase in temperature, it is decreasing. So idometric method and electrometric methods using electrodes are the two methods used for determination of dissolved oxygen. So today we will see only the idometric method to determine dissolved oxygen. Okay, coming to the principle involved in determination of dissolved oxygen. Now, the principle involved in determination of dissolved oxygen is the dissolved molecular oxygen present in water is trapped by the manganese sulfate which is there. So this manganese sulfate uh, first forms manganese hydroxide and basic manganic like this manganese hydroxide will trap this forming basic manganic oxide. And then when you are acidifying it with concentrated H2SO4, this will release this dissolved molecular oxygen as nascent oxygen. Now, nascent oxygen is highly reactive and it will immediately oxidize iodide. Ki is there, K plus I minus. Okay, so this I minus is oxidized to I2. So this is how I2 is released. Once I2 is released or liberated, we measure how much I2 has been liberated. How much I2 will be liberated? You are adding excess of Ki. So it will release only that much I2 as that much of nascent oxygen form. How much nascent oxygen has formed? As much of O2 is there. And we measure this I2. I2 measurement is idometric method. Idometric. If I2 is consumed in a reaction, that sort of reaction is termed as Idometric titration. Okay, so idometric titration is here we determine the iodine using sodium thiosulfate, which forms sodium tetrathionate, and finally we use starch as an indicator and we determine this. Okay, now first we will read this and again we will come to these reactions. These are very important reactions. The principle involved in the determination of DO is to bring about the oxidation of potassium iodide to iodine with the dissolved oxygen present in the water sample after adding MnSO4, NaOH and Ki. Okay, so when MnSO4, NaOH and Ki is present, the dissolved oxygen will oxidize iodide to iodine. The basic manganic oxide formed from NaOH and MnSO4 acts as the oxygen carrier to enable the dissolved oxygen in the molecular form to take part in the reaction. So it will combine with this manganese hydroxide will combine with the role of manganese hydroxide is to trap this dissolved molecular oxygen. Once this dissolved oxygen forms uh, basic manganic oxide, so Mn2 plus to Mn4 plus is forming, and this manganese is or manganese hydroxide is capable of getting like converted or getting oxidized to Mn4 plus by just this dissolved molecular oxygen. This dissolved molecular oxygen can't directly oxidize iodide to iodine, and that is why we use this manganese. So manganese, basic manganic oxide is formed. So this basic manganic oxide formed wherever the DO present in sample. The DO present in sample oxidizes the Mn2 plus to its higher valency Mn4 plus, which precipitates as a brown hydrated oxide after the addition of NaOH and Ki. Okay, so what is added? Alkaline iodide azide reagent, like we have seen earlier here. Alkaline iodide azide reagent. This comprises of NaOH. So in a liter of water, 500 gram NaOH is added, 150 gram of Ki is added, and why there is no addition of, and sodium azide also. And sodium. Okay, so the quantity of sodium azide I'll find out and then I will write. So for the time being, this is the solution. So it contains NaOH, Ki also. So first of all, in your in the water sample, MnSO4 is added, and after MnSO4, 2 ml of this solution is added, which contains like all those things. Okay, so the DO present in the sample oxidizes Mn2 plus to its higher valence Mn4 plus, which precipitates as brown hydrated oxide after the addition of NaOH and Ki, or alkaline iodide azide reagent. It should be written here. On acidification, the manganese reverts back to the divalent state. Here, when you are having basic manganic oxide brown precipitate, this Mn4 plus, on adding concentrated H2SO4, this reverts back to Mn2 plus and nascent oxygen is released. So on acidification, reverts back to divalent state, and an equivalent amount of iodine is liberated from the uh, Ki present. Ki is present in excess. So this liberated iodine is titrated against sodium thiosulfate, that is Hypo solution, using starch as indicator. Okay, so write these reaction. Very important. MnSO4 plus twice NaOH gives MnOH twice plus Na2SO4. This MnOH twice plus O2 gives twice MnOOH twice. This is a basic manganic oxide which is brown in color. Then MnOOH twice plus concentrated H2SO4 gives MnSO4 plus twice H2O plus nascent oxygen. Twice Ki plus H2SO4 plus nascent oxygen, it gives you K2SO4 plus H2O plus I2. Now this iodine I2 plus twice Na2S2O3, sodium thiosulfate, gives formation of twice NaI plus Na2S4O6. This is sodium tetrathionate. Write down sodium tetrathionate here. Then I2 plus starch. Are you writing? How many of you are writing?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So write I2 plus starch gives you starch iodine blue colored complex. This is not starch iodide complex. I am again repeating. This is starch iodine complex, not starch iodide complex. I minus के साथ complex नहीं बनाता starch. Starch will form complex with I2 only. Starch iodine complex. So the color of the solution when you add concentrated H2SO4 from brown precipitates, the solution becomes clear yellow, and this clear yellow solution you have to first titrate with hypo solution so that it becomes pale yellow. When it becomes pale yellow, you add starch to it. Starch leads to formation of a starch iodine blue complex. Now this blue complex further you titrate ahead of that to get a color change from blue to colorless. So you get formation of starch iodine complex will break at the end point due to this sodium thiosulfate, leading to formation of twice NaI plus sodium tetrathionate, and the starch is set free. So this starch which is set free is colorless. So the end point is blue to colorless. Things are clear? Should I go ahead?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now, there can be interferences if the water sample contains lot of nitrite, iron, and microbial mass. Then, if they are present, they will consume the dissolved nascent oxygen here. This nascent oxygen will be consumed by these species, and therefore your titer value will be lower, or you will report a lower dissolved oxygen present, because dissolved oxygen will be like whatever it is, but the interfering species are there that will uh, ultimately give you a result with showing that dissolved oxygen is less in quantity. Okay, so to remove these interferents, sodium azide is added, NaN3. Now, NaN3 in presence of H2SO4 forms hydrazine acid, HN3. Now, this HN3 is capable of converting your HNO2 nitrite to N2O plus N2 plus H2O. So that this is how this becomes free of nitrite. Now this is a BOD bottle which is shown here. This has a 300 ml capacity. Now the peculiarity of this bottle is it has the upper part is somewhat longer, and this is a tapering stopper. Now, this tapering stopper, when you release it into this particular place, will go in such a way that there is no air bubble trapped. Water, excess water, like replaced water, will come out and will be here, and that is how the BOD bottle will work. Okay, so this thing we will see later. First, see an important part, procedure. Now, in the procedure, standardization of hypo solution of sodium thiosulfate, because sodium thiosulfate is not a primary standard. So you need to standardize sodium thiosulfate solution. So that becomes your part one. So 10 ml of standard potassium dichromate solution was pipetted out. I'm writing was because when you are writing in your file, you have to write was. Okay. So when you pipette out the 10 ml of standard potassium dichromate solution and transfer it into a conical flask, then you are supposed to add 1/4 test tube of 10% Ki solution. So 1/4 test tube means that on the platform there will be like a test tube with a marker saying that you add this much quantity of Ki solution to it. And after putting Ki, you are supposed to put a pinch of NaHCO3. A pinch of NaHCO3, it will be kept in a petri dish with your hand to like using two fingers, you take a pinch, add it there. Now, what has happened? Um, okay, so when this sodium carbonate goes there, like it will be there. Now, then you shake it and you are supposed to add 1/4 test tube of dilute H2SO4. Now, when you add dilute H2SO4, what will happen to this? This is a strong acid, this is the weak base. So, the moment you add H2SO4, the conical flask will have CO2 atmosphere inside. You swirl it nicely and keep it in dark for 3 minutes. This CO2 atmosphere will stop, will remove the oxygen from the conical flask or replace the air because of formation of CO2, and will not allow, like when you keep it in dark, the photochemical reaction of oxidation of iodide to iodine will not take place. And after 3 minutes keeping in dark, you take it out and uh, and then you can titrate with sodium thiosulfate solution. So the reaction is K2C, Cr2O7 2 minus plus 6I minus plus 14H plus. It's a redox reaction. Twice Cr3 plus, wait a minute. What I told you,
It is going from +6 to +3, ma'am.
it is going from +6 to +3, but the number of ions taking part is 6. The valency change is like 2. Tr2. So that is why 6. So whenever potassium dichromate will be taking place, this is the correct equivalent weight 40 times. Every time when you will go for this use of this, it will be by 6 only, molecular weight by 6. Okay? So that is what I just cross-checked. Okay? So at least one student is attentive. Okay, so why it is 49? Because molecular weight divided by 6. So this is chromium plus 6 to plus 3. But number of this thing is 2 here also, like the anion part is 6, which is getting converted to thrice I2. So it will be the number of electrons or number of ions taking part is 6. That is why it will be divided by 6. So this is the I2 which is released. So this I2 will be determined using this sodium thiosulfate. So initially, if the high concentration of I2 is there, then what you get is you can't add the indicator in the beginning. First, you have to, like, it will be dark brown in color, and then when you, let me check whether there are any. But wait a minute, I had another PPT. Just I'll stop sharing this and search for a PPT with the, what you say, photographs and this thing were there, pictures. Colors and all should be at least visible. Okay, can you see this particular PPT? Okay,
Yes, ma'am.
yeah. Yes. So, what is this? This is a BOD bottle. And now to this, like 2 ml of MnSO4 solution is added. Okay. So, in a burette, this big quite concentrated solution will be filled in a burette. So, 2 ml is added from the top. Alkaline iodide azide reagent is highly corrosive because very strong alkali is there. So means high concentration is there. So with the help of pipette, 2 ml has to be transferred in such a way that the tip of the pipette is below the level of water. And then after doing that, you put the stopper. After stoppering, some part of like 2 ml this was added and 2 ml this was added. So some part of water sample will be lost because these being concentrated and these solutions they'll go and settle at the bottom and the upper sample will be lost. So 4 ml sample is lost. You stopper it and remove the solution from here into the sink, and then you allow it like you have to mix the BOD bottle, the contents nicely, and then after mixing it, making keeping it upside down, you have to keep it stand still for around 5 to 10 minutes. Now, in 5 to 10 minutes, all basic manganic oxide MnOOH twice, this brown precipitate will settle down. So all the dissolved oxygen present in this water has now trapped as basic manganic oxide, and then with the help of a pipette, 1 ml of H2SO4 is added. So when you add 1 ml H2SO4, the basic manganic oxide will Mn will convert into Mn2 plus, and iodine is released because Ki is present in this solution. So as much of nascent oxygen is formed, that much of iodine is released, and this is the I2 iodine which imparts a yellow color to this BOD bottle. Okay, then when you are taking, you take the quantity of the specified quantity into conical flask, and you have to first titrate. You can't add this indicator in the beginning. You are adding indicator at the end. So you first titrate with sodium thiosulfate solution till you get a pale color. The comparison of the color is there. Like this is the initial color. This one. So you titrate till it becomes pale yellow, and when it is pale yellow, this is the starch. With this, you add around 1 ml of starch to it. So when you add 1 ml of starch to it, see the moment it is dropped, it forms a blue colored solution. So that is starch iodine blue complex. And after this is your chemistry lab. So when it becomes blue colored complex, you are supposed to titrate with hypo solution again till it become colorless like this. Now when it becomes colorless, the total volume is corresponding to the dissolved oxygen present, and then we can go for the calculation. Okay, so I think this was explained. This was also explained. I told you regarding the procedure, how it is done, what are the color changes, and this is initially you take uh, like the tap water is collected in a bucket because we don't want air bubble to trap inside. So tap water will be collected in a bucket and the bucket will be kept. And from the bucket you have to fill your BOD bottle and then you stopper it. Remove the excess water which will be at the top and then go on adding 2 ml of MnSO4 and 2 ml of alkaline iodide azide reagent, and then as I told you, after adding 2 ml of these two things, 2 ml of MnSO4, 2 ml of alkaline iodide azide, it contains NaOH, Ki, and sodium azide. Okay, so it leads to formation of a basic manganic oxide brown precipitate which settles down, and after settling it, you will add 1 ml of H2SO4 to it, so it releases iodine. The iodine released is equivalent to the dissolved oxygen, and we can determine how much iodine is released. So So you titrate with hypo solution first, sodium thiosulfate, till you get a pale color. When it is pale, you add starch indicator and get an endpoint from blue to colorless. Okay. So the standardization procedure, I think we were discussing Cr2O7, 2 minus plus 6I minus plus 14H plus. Everyone should write these reactions, the procedure and all in your file. Gives you twice Cr3 plus 3I2 plus 7H2O. Then I2 is determined with thiosulfate, and at the end point you add starch and you get a color change from blue to colorless. So titrate the liberated iodine with this and get the burette reading. Say the burette reading. Take a screenshot of this so that you will write these readings, this observation table into your column. Okay. If Ki is not iodine free, a blank experiment has to be performed and the corresponding correction should be made to the titer value. Okay, so this is potassium dichromate taken 10 ml. To this you are adding H2SO4 and the standardization part H2SO4 Ki solution 1/4 test tube and a pinch of sodium bicarbonate, and you keep it in dark and then you perform. You get a constant burette reading 10.1 ml. You get the normality of sodium thiosulfate solution from this particular 10.1 using 10.1 here as we do, and that will give you the calculate that part in your file. Okay, so your file should contain this. Write these things properly because this is N1V1 which corresponds to dichromate, N2VT to sodium thiosulfate. Okay, then determination of dissolved oxygen, titration with water sample. For DO determination, water sample is collected in 300 ml BOD bottle, avoiding entrapment of air. Add with the help of graduated pipette 2 ml of MnSO4 followed by 2 ml of alkaline iodide reagent in such a way that the tip of the pipette should dip below the liquid water surface while adding the reagent. Then stopper the bottle immediately and mix well by inverting the bottle 2 to 4 times. Then allow to stand for 2 minutes. Add 1 ml of concentrated H2SO4. Generally, this addition is done by the attendant. Concentrated H2SO4 you are not allowed to handle. Insert the stopper and mix well till the precipitate goes into solution. Allow to stand for 5 minutes. Take 200 ml of the clear solution into the conical flask and titrate hypo solution using starch as indicator. Note, when 2 ml MnSO4 and 2 ml alkaline iodide reagent are added into full BOD bottle, from below the liquid surface, 4 ml of the original water sample is lost. Now this 4 ml which is lost is the part which had dissolved oxygen in it, and these things which are coming in are not having dissolved. This is distilled water prepared solution, so it is not having dissolved oxygen. Hence 200 ml now taken from the titration for titration will correspond to 197.3 ml of original water sample. So although you take 200 ml of which solution, this particular solution, this solution which is there. Okay. Now what has happened? You took 300 ml first, you added 2 ml of this, 2 ml of this. So 4 ml was lost from the top, which contained dissolved oxygen. And these two reagents, 4 ml went at the bottom. So 4 ml is lost means 296 is the water sample volume in it. So 296 ml was the water sample out of from which the dissolved oxygen is now trapped in this basic manganic oxide. Now when you add 1 ml, the dissolved oxygen present in 296 ml is already trapped and settled at the bottom. So 1 ml of H2SO4 added will not make any difference because the liquid which is lost is now not at all having the dissolved molecular oxygen, but is free from it because that is all trapped in basic manganic oxide. So this 1 ml of H2SO4 has not to be considered. Then you are taking, because of ease of measurement, 200 ml for titration. So a large conical flask you will take and you will transfer measuring with a cylinder, measuring cylinder. you will transfer it into this. So using a measuring cylinder, when you transfer a 200 ml here and perform the titration, the calculation says that you are transferring actually 197.3 ml of the original water sample. How 296 ml sample is present in 300 ml of mixture solution. So if you are taking 200 ml mixture solution, it is 197.3 ml of the water sample which contain dissolved oxygen. Okay, so same thing we will use here. So when you go for the observation, there is only single titration of this 200 ml. So that has to be performed properly, and you will write the volume of sodium thiosulfate solution required. You are given a reading 7.8 ml. Okay, so the calculation part will be dissolved oxygen will be volume of sodium thiosulfate solution into the equivalent weight of oxygen, that is 8, by the volume of water sample taken. Okay, so here the volume of hypo solution is the normality of hypo. Wait a minute. Volume of hypo to okay. Okay, are you getting? Are you there? How many
Yes,
of
ma'am.
you are
Yes,
here?
yes.
Okay.
Yes,
Yes, ma'am.
Yes,
Yes.
ma'am.
Yes, ma'am.
Yes.
Yes.
ma'am.
Okay, since it is prepared in like a PPT way, no? So, certain things goes like some corrections come every time you open this particular thing. So dissolved oxygen will be volume of hypo in the normality of hypo divided by the volume of water sample taken into the equivalent weight of oxygen will give you in grams per liter of oxygen, dissolved oxygen. Now you multiply the volume 7.8 into the normality of hypo that you got in the standardization process divided by the volume of water sample taken was 197.3 ml into 8 into 1000 will give you ppm or milligrams per liter, and that is what is written. Dissolved oxygen in the given water sample is equal to this milligrams per liter or ppm. So precaution, pinch of NaHCO3 may be added during titration of hypo solution. These are the precautions that you are supposed to take. Okay,
Ma'am.
after addition of reagent, BOD bottle should be stoppered and shaken well. Starch should be added towards the end point. Azide solution is added to avoid interference of nitrite present in water, and overflow of water in BOD bottle during addition of reagent should be taken into account during calculation, etc. Okay, so these are the precautions. So this is the experiment you will write in your file.
Ma'am.
All the batches can use this experiment for writing. Yes.
Ma'am, what to write in that fill in the blanks while writing the file?
कहाँ पे fill in the blanks?
Next slide. Yes, ma'am. Yeah. Result.
ये आप करो ना कैलकुलेट। अभी आपने क्या किया है, दिस इज द स्टैंडर्डाइजेशन पार्ट, दिस इज द रीडिंग गिवन टू यू, ठीक है। तो सब्स्टिट्यूट द वैल्यूज यहाँ पे 0.025 into 10 divided by 10.1 ml. What you get, that you write here. So that becomes the normality of sodium thiosulfate solution. सब तो दिया है आपको।
Okay, ma'am. Okay.
What will be the normality of sodium thiosulfate? 0.025. N by 40 means 0.025 into 10 ml is the volume of dichromate. The normality and the concentration of normality of dichromate and volume of dichromate is this, divided by V2. V2 is 10.1 ml, that is volume of sodium thiosulfate. तो आपका रीडिंग क्या आएगा यहाँ पे, molarity, normality of sodium thiosulfate will be like this into this divided by 10.1. तो थोड़ा सा कम आएगा, 10.1 है तो 0.024 something like that, 9 something like that it will come. So whatever is coming you have to write here. Once you get that, then you have to substitute this value here, V3. V3 दिया है यहाँ पे 7.8 ml. So you write 7.8 into the normality of hypo which you got during standardization divided by 197.3 ml into 8 into 1000. यहाँ पे जो डॉट डॉट दिया है ब्लैंक, the blanks are to be calculated using these. समझ में आया? Everyone got this?
Yes, ma'am.
Yes, ma'am.
Yes, and that will be your result. और result लिख के आपको upload करना है. What date I gave you? 16th.
Yes, ma'am. Yes.
16th of
16.
January I told, na?
Yes.
Yeah, I will let you know where you have to upload. Okay. So this experiment is clear. This is common for X1, X2, and X3 batch. Okay.
Ma'am,
All
tomorrow batch will having a experiment for.
No. Neither X2. Today.
Okay, ma'am.
Okay. So don't wait for that. When I am taking separately for the 3 batches, I'll let you know.
Okay, ma'am.
Okay.
Okay, ma'am.
Okay, ma'am.
Yeah, and that will be like Viva. Mostly your Viva will be there when it will be taken separately. Clear? Okay. Anyone having any doubt? We can anytime open this. It is there, and we can anytime open during like any student. Just feel free to say that, Madam, I didn't get this. We will just go through again. So we can open this and see these things. See, I had opened one other file in which the photographs were not there. So with photographs, number of things become clear, right? Isn't it?
Yes, ma'am. Yes.
What exactly
Yes,
is happening, what is done, and what is the color change, when to stop, when it is called as pale yellow, when it is pale yellow, then you are adding starch to it. All those things. Okay. So write the experiment, keep it ready for submission.
Ma'am, will you share this experiment PDF?